This video is about what causes electromagnetic force at the subatomic level and what brings it up to the larger scales. First of all, we know that the particles of like charges repel each other and those of alike charges attract each other. So the question is how they know if they close enough to one another to make this force. And the answer lies in the fact that the electromagnetic force is carried by the virtual photons at the subatomic level. Yes, the photons as in the visible light electromagnetic waves. And in a common sense, a particle is matter with some mass, not force. But actually, maybe you've heard that at the quantum level, things go crazy. So here, we've got the photons having no mass and being just packages of energy. And we talk about the word virtual. This particle may be a proton or a neutron or an electron. Or whatever it is, it's emitting the photons and these photons are bouncing back into this. And this is happening all the time. And each of these photons only exists for a very small amount of time, so it has to come back quickly into its parent particle. Of course, you need some amount of energy to produce these photons. And this is allowed by the uncertainty principle. We'll see this. Delta E times delta T approximately equal to h bar over 2. And h bar is a reduced Planck constant, and this whole number is of a very small value. And for the amount of energy required to produce these photons, we can allow very much of delta T. This delta T is very small, very short lifespan. So it's too short and these photons can even be called real. So they're called virtual photons because they come back into this and disappear in a very short time. So if two particles are brought together, this particle produces virtual photons and it might reach this. And this particle produces its photons and it goes here. So the exchange of virtual photons decide these repulsive and attractive force. So the cause of electromagnetic force is the exchange of virtual photons at the subatomic level. Well then, for largest level, and each particle has its own electromagnetic field, like small magnetic bar in it. Well, actually the nucleus has a very weak electromagnetic field, so in an atom the electromagnetic field of an electron governs. But we can go to the Pauli's exclusion principle for detail. But anyway, basically in most atoms, and two electrons are paired up and they have the opposite directions of magnetic fields, so they cancel out. That's why most objects around us don't show their magnetic property. But in some atoms, there comes a net magnetic field. These two cancel out and this is net a directional magnetic field. So if such atoms with a net magnetic field comes together in a domain in group of those atoms, we have a net direction of magnetic field. So then again, if those domains come together, we have a magnetic object at larger scales. This is how electromagnetic force work.